Okay, now let's start. Okay, this time we will learn something a little bit easier compared to last time, the area of a triangle. Okay, so area of a triangle, I've heard that some of you have already learned it. So for area of triangle, I want to check who have learned the area of a rectangle. So we will make use of the area of rectangle to get the area of triangle. I guess some of you may have learned this part. So today, if you have learned it, that's good. I want to consolidate your learning. If no, then you can follow my teaching, okay? So area, what is area? We want to find out how big certain figure has enclosed, okay? This is area, okay? I want to know how big is this part has enclosed. If I just want to know the boundary, the length of this boundary, do you remember what do we call it? I want to know how long is this green line. Yeah, Rachel?
It's called perimeter.
Yeah, perimeter, okay? So perimeter, we talk about how long is this boundary. For area, we want to know how big this part has enclosed, okay? For area of triangle, we need a triangle. So triangle, there are different parts in a triangle. A, B, C, we need 3 points. These 3 points, we give it a name. They are called the vertex, okay? Vertex is the singular form of the noun. If you have more than one vertex, we call it vertices, okay? And with ICES, so vertices. For a triangle, there are 3 vertices. For 3 vertices, we can have 3 straight lines formed, and they are called the side of the triangle, okay? Now, for finding the area of the triangle, we need some information from the triangle, okay? Later on, we will find the heights and the base of the triangle. So when you look at these 3 triangles, do you think that some are taller, some are shorter, right? Yeah, you feel that some are taller and some are shorter. So whether it is taller or shorter, we talk about the heights of the triangle. So how can we draw the heights of the triangle? Do we draw any straight line from the top vertex to the bottom line? Can we call it to be a height? Or can we call this green one to be the height? Or can we call this black one to be the height? Which one should I pick? Rachel again?
The green one.
Why?
Because the black and red are on angles and that could change the length.
Yeah, okay. You can observe that when I have the red line, there is a certain angle here, right? When the angle gets smaller, the line gets longer, right? So this may not be a good option for the height of a triangle, okay? So for the height of a triangle, we pick the shortest one. Actually, where is the shortest one? The shortest one is from one of the vertex to the bottom and make a right angle, 90 degrees. Okay, this will be the shortest one. So we call it the height of the triangle. Okay, so when you have the height, it corresponds to a base. Okay, base refers to the straight line that is in 90 degree with the height. So this is the base. All right. So for the first triangle, I have this to be the height, and this will be our base. All right. For the second one, I drop a straight line 90 degree to the bottom. Okay, this is our height, and the base is this side will be the base. Okay. For this one, also I drop a straight line. It has to be 90 degrees. Sometimes it gets out of the triangle. It's okay. It is still our height of the triangle. Okay. So you just extend the bottom line a little bit. You will see the 90 degrees. And this is the corresponding base. All right. However, for a triangle, if you still remember, I've just mentioned, there are 3 vertices. Okay. There are 3 vertices. The height is formed by dropping a straight line, a perpendicular line from one of the vertices, okay? I can choose this vertex to drop the straight line, okay? So that I will have this to be the base. However, I can also choose this one, this vertex, to be the end of the height, I can also drop another straight line, okay? So for a triangle, actually, we have 3 pairs of heights and base, all right? 3 pairs, okay. I have mentioned there are 3 vertices in a triangle. Therefore, we have 3 vertices. Oh, sorry. We have 3 vertices, so we have 3 different pairs of...
They're called vertices.
Oh, vertices. You call it vertices. Okay. Okay, heights and base. Okay, 3 different pairs of heights and base. All right. So the first task is you need to identify the heights and base as a pair. Okay. If you have a height dropping from A to BC, this is the base. Okay. This is the height and this is the base. If you have a height dropping from vertex C to AB, now AB becomes the base and then CE becomes the height. So you will see that if the height has changed, the base will also be changed. Next, if you have B to be the vertex, okay, you drop a straight line to AC. Now AC will be the base and then BF will be the height. Okay, so it depends on the vertex that you have chosen. You will have different heights and base. All right. So this kind of triangle, you will see that all the heights are within the triangle. There are some of the cases that the heights can be outside of the triangle. If you pick vertex P, you need to drop a straight line, okay, a perpendicular line. You can see that the line you draw here is outside of the triangle. So how can I present the right angle? What you need to do is extend the base, okay? So that it meets with the height and you have a 90 degrees here. But the base will still be RQ instead of RS, okay? QS is the extended part. We don't want it to be the base. We want it to be RQ as the base. Next, you have R. You drop a perpendicular line to PQ. So PQ and T, they don't meet. So you extend Q to T so that RT and QT, they meet at a right angle. The last one, you will see Q when you drop a perpendicular line to have PR to be the base. This height is within the triangle, okay? So either one is okay. It depends on which one you find it more comfortable with, and it depends on which one you have given the some information on it, okay?